Yeah, in the past when passwords were a little bit weaker than we got right now, my last name could be probably working as a password. I'm from Poland, and this is where it comes from. Just of course tell you a couple of things about the session, and we are starting. So as you can see, we've got a Mike basically on the slide, but Mike will not be joining today because of his personal matters, so I will do that session by myself. But I guess it's all right because this is also part of my research. So let me of course do a couple of interesting intros, and then we are immediately heading back to the presentation. So as you already know, I'm Paula. And what I'm simply doing for a living, it's cybersecurity for the past, that sounds quite crazy, 20 years. And my company, Secure, it's something that I have established 15 years ago, or 15 and a half to be precise. And we are placed in 4 locations in the world: New York, Dubai, also in Switzerland, and also in Poland. So our team has grown a little bit. Right now my team is 65 people. So it has been a fantastic journey within this time in cybersecurity. And my background is very, very clean. Like, I've been always doing pen testing, but there's a moment where I decided to switch a little bit towards incident response forensic. Because pen testing is cool, it brings you adrenaline, but there's a certain moment where it starts to be, let me put it delicately, less interesting, yeah? Because you are getting in, like, using the same tools, using the same vulnerabilities, using the same paths. And then it's just like when things are not exciting, then it's obviously time for a change. So incident response and forensics definitely adds a lot of adrenaline to my life, especially, for example, during the weekend. We had a customer that was completely smashed by ransomware, and they don't have a backup, and it's probably a scam, and they're asking to pay, but probably they're not gonna get anything. So it's a big, interesting battle always. Anyway, that's my job. I do have basically also access to the source code of Windows. This is legally given by Microsoft. And I'm also Microsoft Regional Director, but I do not work at Microsoft. Yeah, so it's a very external role. So don't be confused because it's Microsoft means kind of Microsoft Director Regional. Yes, sounds like a position, but it's a very honorable role for people from the outside that are basically engaged in technology. And apparently, that's what they say, do something innovative. Well, they gave me that, so I took it, so it's good. But anyway, so it's absolutely a pleasure to be here once again, yes, another year, and so on, because this is also a moment where basically, I really enjoy RSA conference and meeting with you guys, just to be honest, yeah, and there's always something interesting to share. So please, this is the QR code. It's a link if you don't want to enter it, just for the reference. Yeah, we know things about QR codes. So you can also enter a link, and over there you're going to find presentations. Yeah, so tools and slides that basically I'm sharing. So you can sit comfortably in the morning and enjoy what we're going to be talking about. And what is absolutely important is that I have to say that this presentation is intended for the educational purpose. Yes, we're going to do a lot of nasty stuff. Yeah, but it's for the education, you know. Yeah, so you know the drill. Okay, good. So let's do it. Today we are talking about Data Protection API and Data Protection API NG for the new generation. And you might be wondering, why that precise subject? Because literally every single thing in cryptography in Windows that moves, it's basically somehow related with the Data Protection API. So for example, if you are using operating system like Windows, you need to know precisely that when you store your data in a certain way, it's going to be safe or not, and under which conditions that's going to be the case. And the research and the practical demos that I'm going to present today, they are actually relying on over 2 years of sweat and tears and stuff, because we are, and I'm not bragging about it, don't get me wrong, but it's apparently a fact, we are the only and the first team in the world that did the reverse engineering of the Data Protection API. And I would love to share with you, of course, what does it mean to be safe and under which conditions you are actually safe. You can see here that 64% of organizations do not have a cybersecurity incident response plan. What is also interesting is that we've got 83% of businesses, they involve, as you can see, external actors. But when you, for example, jump into an incident, like I happen to do, quite often it appears that it's not like, you know, there's like a whole advanced army of hackers attacking you or something like that, but it's usually something simple. It's usually, for example, a user that has a simple password, or the user workstation that is attacked through phishing, this, and that, and then you are like, wow, you put on the one side of the scale a user with a simple password, and on the other side of the scale, you put like a whole multi-million, billion organization, and this affects that, and that's really sad. And we might be thinking, okay, why is that so? And that actually, data protection API, it's very much in the background of what we're gonna be talking about. So let's start. First of all, sorry, I have to warn you because I've forgotten, because it's kind of like my job at the end, but are you ready for a technical ride today in the morning at 8:30? And I apologize. Good, okay, good, thank you. Just a warning, yeah? So it's a technical presentation. I will do my best to build a picture around like why do we need things and so on, but I have to torture you a little bit because it's this kind of a subject. So most often used algorithms in Windows. Most often, not everything, most often. So this is the set. Now, why this is important to know that? Well, because within the data protection API, things are protected in that kind of a way. To be honest, you want it or not, to be honest. Because, like, you can choose, for example, when you have PKI implemented, that you want to, for example, use that type of an algorithm, that key length, and so on, fine. But in system functions, you simply cannot. Or sometimes maybe you can, but it's not really that obvious path, actually, to move on. So what we're going to start with, it's a system secrets. And let me explain the very beginning of the system secrets so that we got to the base of the next one, which is user secrets, which we are heading to. So, most of the system secrets, most of them, they are relying on something that we call a boot key. Now, what's the system secret? As you can see on the right side, it's going to be some database, ntds.did, LSA secrets, MSDCC2, so something that people call cache credentials, but it's not really credentials, which we're going to be talking about, but also computer account passwords, also, for example, Wi-Fi password, and so on. So these are the system secrets. Now, they all depend on what is stored in the system hive in the registry. So, for example, in a case of services, which is very interesting, and let's start with something lightweight, we've got a situation where basically we're capable to extract the passwords, of course, from the service passwords for service accounts that are stored in the operating system. In fact, let me show you how to do it, and then we're going to get into some technical details of it. So here we go. First of all, whenever we get into the service configuration in Windows, like you can see over there, I've got the Paula service. It's actually running on the Freddy Krueger's account, yeah? So this account, it's disabled, but it doesn't really matter. So this particular password, when we go into the logon section, you can see it's like in dots. I mean, it's stored somewhere. It's actually stored in a registry. It's stored in a registry in the revertible way. And it's so important to remember that under two conditions. First of all, when the password is stored over there, then we've got a possibility to do CQ, secrets dumper, and then service, PJ service. This is our tool. We share it for free, no registration. That QR code that I was sharing, you're going to find it over there. Please use it. It's a cool tool. So PJ service, and what I'm getting over there is a password, just like that. Yeah, so this is basically how it's stored in Windows. Now, if I go regedit, and then basically from that level, I'm going to go to the HK local machine security policy secrets. Let me enlarge the path so that we got it. Yeah, so you can see that that's this one in security policy secrets. By the way, I think it's like calling some registry hive secrets. It's always very cool. Like, it's like for sure nobody wants to get there. Yeah. So it's like secrets, and you're like, yeah. And indeed, you're going to find things like that. So there is a current value. Have a look. That this is basically that encrypted secret. So the password that we were able to pull out is actually a version of that, but decrypted. Now you might be thinking, okay, but how is this tool working? Well, here's an answer for you. So as I mentioned, you can download the slides, you can have a look, that's a little analysis, but if you're wondering how the tool works, basically how to extract these passwords, that's literally one-to-one way. But for us, what is important is that when we say like, yeah, but we can, for example, replace the regular user accounts with that GMSA, group managed service accounts, so that password is no longer there. Hold on, we are here for one thing for sure, to discuss lots of things in cyber, and that's gonna be one of these that I will say, okay, let's get rid of this problem. And I've got an account called Corner, for example, and this is the GMSA. Here we go. That's it. Okay, apply, yeah, and I'll enter the valid password because I have to clean it up. Apply, okay, great. And in fact, I can actually make it automatic, and then I can start it, restart it. It doesn't really matter because password is stored there anyway. And we are thinking, okay, can I still get a password? And let's have a look. Answer is, as you will see, I can. And the reason why I can still get a password is because it's a bug. So if you change the regular account to the GMSA account, you have to remember that you will go to the registry and clean this trash out. That's step number one. Or you can fix it by changing it to the local system, apply, and then put your own GMSA account. Yeah, for the reference. So just a little warm up over there so that we've got information where the passwords are stored, and there are so many places that we're gonna be, of course, touching base on. Good. Now, the next part. Easy, but not easy. Getting a hash. So we've got NTDS.dit and SUM. SUM database, of course, it stores MD4s of the user's passwords, but the SUM database itself, it's also a secret because as a file, it's encrypted. How? Indirectly by using a boot key. Yeah? So once we get the boot key, once we get the SUM, we can actually work on it and also on NTDS.dit to get the hashes out. It's very, very easy. So just to show you the little methodology, because it's also important and it's actually quite funny. I find it, this is my sense of humor, it's very dry. But if you have a look at the point number 2 over there in the slide, just imagine, this is how I imagine it, don't get me wrong. So the developers are sitting in a basement, let's say 25 years ago, designing how to protect SUM, and they designed some kind of a key, and then the other guy says no, that's too short. What do you mean it's too short? Just make it longer. And then the other guy is like, okay, so quote, exclamation mark, at hash, dollar, QWERTY, and this guy says it's still too short. He's like, all right, Q, yeah. I mean, it's a flat value over there, so you are wondering, what's the history of that? But anyway, and then it's yeah, let's add some numbers, 0, 1, 2, 3, 4, oh, wow, okay. Anyway, we use that as a part of the key to generate a key, and step number 4 and 5, it's a key to success, so it's a key on a key on a key on a key, and then at the end we end up with a key that decrypts as SUM so that we can get the hashes out. So if someone takes your SUM, it's okay. Yeah, well, it's brute forceable, so maybe not quite right, but it's not that someone's gonna get hashes immediately, definitely not. So let's have a look into the ways of how we are able to get these things. And this is, of course, very easy because we need to always have a tool for that. But for SUM, it's extremely easy, so I'm gonna just do it just like this to show you that it's extremely easy, actually. And then we do CQ hashdump version 2, SUM dump, enter, and then the hashes are coming out. Yeah, so that's extremely easy. But for the NTDS.dit, that's a little different story, to be fair, because we've got a possibility to actually extract more things from NTDS.dit. And that's going to be exciting because I'm going to be explaining right now a little bit of an introduction to the user secrets, and that is something, honestly, that everybody in cybersecurity has to know about. So let's start the introduction to the second section. So we're going to do over there CQ NTDS DT decryptor. First thing also to mention, we have over 200 tools that we wrote for pen testing and for incident response. And we just think, okay, there is no tool in the market for that, let's write it, and then bring it on, we get a tool. The names, this is actually a short name of the tool. Sometimes the names are like this, because it's very descriptive, so that you know what the tool does. Because if you got that many, it's hard to really control it, yeah? So don't be discouraged by the names, they actually have a meaning. So we got a CQ NTDS DT decryptor, and then we can see that we have to put in the boot key. We have to also specify a file, so NTDS.dit, out file, like hashes.txt or something, but then key to success is this KDS root key file. And that is the KDS root key that's stored within the Active Directory domain controller, and this has to be reset after the attack. In fact, not many companies, they got a list of how to recover your Active Directory after the attack, and there's actually over 40 points that you have to do. And this is basically one of the things, yeah? Because lots of things in cryptography in the Windows infrastructure rely on that. So that is to be reset, but I will talk more about that later on. So let's do a little bit of an access. So first of all, the boot key. In order to get the boot key, I have to do the CQ, secrets dumper / boot key, and then specify the sys, where it's going to be the path for tools, ntds.dit, and then basically system, for example. And I've got the boot key here. Yeah, so this is how boot key looks like. So pretty short, yeah, as you can see, and this is relying on the class names from the couple of values in the registry. So let's take that particular boot key. So it's a very easy step, really. So then we're going to get into NTDS decryptor, boot key, and then we're going to put that on. And then we're going to put the file, and the file is, in fact, tools, ntds, and ntds.dit. So we are extracting hashes right now from the ntds.dit database. And this is it. This is it. Like, I don't need more. But, of course, for the presentation, I will do out file, hashes, txt, for example. And then the next part is that I will here specify the KDS root key. So the KDS root key, and kds.bin, yeah, like that. So after a moment, as you can see, we've got a situation where basically we've got the export, and we can in fact open hashes txt and see what's gonna happen. And I got it on my second screen, it's just opening, so I will put it out in a second. What we got over there is that we will be in fact, getting into the hashes, and this is basically the hashes that we got. Yeah, so that's the one. So this one is easy, but the most interesting part is this one: found KDS master root key. So what kind of stuff we would be able to do with this, and why we have 3 of those? So here is the story. Every organization that's using Active Directory, and it doesn't matter how old it is. Yeah, it could be whatever old. Then you are in your lifetime generating KDS root keys. And even like when you've got a big enterprise, it's going to be approximately 3 or 4 max. Yeah, so it's not much to work on when there is an unfortunate situation under attack. But that KDS root key is something that we're going to steal, and we're going to be using it to access different protected files. Yeah, so that's like the first step over there. So I'm going to keep it here for the moment, and let's get into the second part. So we worked on the passwords for the service accounts, passwords, so the SAM databases, the ntds.dit, IIS also relies on that, but let's get into the user secrets now. Now this is where the party begins, truly, because in the data protection API, in order to be able to extract secrets, you need to first analyze whether the user, it's a domain user or a local user. Now why that matters? Yeah, so it matters because local user, in fact, it's protecting its secrets. So let's say password stored in Outlook, for example, or password stored in a browser. Yeah, so it's protecting its secrets, relying on its own hash. But think about it. If the user would rely on MD4, local user, then there will be no protection. Why not? Because if someone manages to get access to the SAM database, we get the hashes, so we get the secrets of the user. So it's not really working well. So in the case of a local user, there is a twist, and the secrets are protected by using SHA-1. And you are like, yeah, wait, SHA-1? Isn't that we are like getting rid of SHA-1 a long time ago already? Like, it's not really something even to talk about, right? But anyway, that's what it is. So that's what I said. You want it or not, lots of things like that are in use. And unfortunately, SHA-1, it's a thing. So here we go. But for the domain user, it's MD4. Now this is point A1. Yeah. Now I'm going to actually make a picture, if you don't mind, because my goal right now, it's going to be to completely violate the whole domain. And this is like a drama story over there, because if we wondered, what's the chance that our domain admin that we were like hiring, let's say 10 years ago, is still there? Yeah, so like a hidden threat actor. And we might be like, oh, that's an over-exaggeration. Hold on. There are a couple of things that you cannot change. You cannot change. And this is something that I would like to talk about. It's a very sad momentum for the presentation, because in fact, I'm going to talk about things that you cannot fix. The only things that you can do is to build a wall around it. But let's, of course, talk about these things. So first of all, whenever we are looking at the data protection API, what's the point? And here is the picture coming. And I'm going to use my finger actually for painting this so that everything is like super clear. And let's do it this way. First of all, we've got a secret to protect. So that's going to be our, let's say, password stored in a Google Chrome, for example, or password stored in Outlook. So users do that. That's the point. Everybody does this. That's the point. So under which conditions we can completely mess up and extract that password? So have a look. We've got here a local user. And I'm going to be obvious right now, but let me explain it. Local user logs in. And we are logging on with the username and password. And of course, there is a SAM database, right? And that SAM database stores MD4s. We are calculating the passwords hash on the top of the passwords, comparing we are logging on. This is easy, yeah? But now, what's happening is that on the top of the password, we calculate SHA-1, as we said. And that SHA-1, it's encrypting something that we call a master key that's stored in the master key container. That's a fancy name for a file, just for the reference. It's just a file, basically, yeah? Let's put it straight. But master key, though, it's like a randomly generated value that is directly or indirectly, depends on the implementation, protecting the secret. So if you store the password in a Google Chrome or in Outlook, let's keep it as a motive here, then that password is protected by the most probably master key, and that master key relies on your user's credentials. So I get a question to you guys now, and tell me whether it's true or not, true or false. So I could make a statement, maybe, that my secrets are as well protected as the strength of my password, based on this graph. And I'm not tricking you. True or false? True. Right, okay, true. But, there's always some but, right? So like little asterisks hidden and so on. But, if you switch off hibernation, but if you have a BitLocker protection, because eventually your secrets are dependent on the strength of the password. I mean, we can see the harder it's going to be to crack MD4 to get the clear text passwords to calculate on the top of that SHA-1, the harder it's going to be to decrypt the master key so that you can get the secret. Yeah? Easy. Okay. But the point is that in the hibernation, when you got it, the SHA-1 is actually written in a clear text. So that's not good, as we can say. So this is actually one of the master tips, I would say, for this kind of activity. But then, let's make it interesting, because we're going to be talking about the domain user. In the meantime, is it okay, clear for now? You're silent. Good? It's going good? Okay, good. You're nodding your head, good. So let's move forward. So have a look. We've got username and the password. Domain. This is for the domain user. Here is a domain. Okay. So we log in. Kerberos, NTLM version 2, doesn't matter. Now, we've got, of course, ntds.dead, and we've got here, we're working on MD4s. But now, we are also calculating on the top of the password MD4, and that MD4, it's protecting the master key 1. That's protecting the secret in the master key container. Now, because there is a master key 1, this model we know already from what we got in the left, there is also master key 2. So let's put it on. Master key 2, which is also protecting, of course, secret. Master key 1 is the same, clear text, as the master key 1 as master key 2. But the question of the universe is, who is actually protecting master key 2? And that's what this presentation is about. Because it is actually protected by the public key of the domain. Public key of the domain. I bet you have some questions right now. Where is the private key, right? Who can actually get access to every single user's master key too? And the answer is whoever possesses private key from the domain. Okay, what's the private key of the domain? Like, what is it even? This is actually our discovery. So have a look. And of course, demo is coming. So once we're going to get into the domain controller, and this is my domain controller, let me extract that private key. Yeah? So whoever has a privileged access in the organization, this, for everybody's sake, has to be a very audited role. And I know you know, but there is one problem with this. The problem is that if we're going to get into that private key, there is no way you can actually change it. And I'm going to use over there CQ ELSA secrets dumper. This is our tool that we spent the years on, so you will see how fast it works. It looks like we're doing nothing for 2 years, but here we go. And then let's just go file and then export that exported PFX. And we are here exporting a PFX, that private key that is responsible for the protection. So I do next. The password is, in fact, secure. Let me show you. Here we go. And then next, and then next. And I don't need to import it, but I want to show you. Cert MGR MSC. And then, when we go to the personal certificates, you can see that there's this thing that's like not available. And this, in fact, it is actually a certificate that everybody having a domain has. So can you get rid of it? No. Can you fix it? No. Can you renew it? No. Can you change the cryptography behind it? No. Whatever you think about right now, answer probably would be no. So that's really the case right now. And you can see that mine is pretty old. Yes, because my domain, in fact, so-called secure.tech that I'm working on in the lab, even though I renew domain controllers and stuff like that, I get new items in it and so on, it's a living domain, I set up actually at that time. So you cannot change the certificate because you're going to lose all the support. Can you work on it a little bit and then like change it for real, but then lose the support? You can change the certificate, yes, but it's a big mess that's going on. So technically, it's possible, but it's like a super rare case. Now, what I want to say is, what do we use this certificate for? And let's make a little case study, shall we? So whenever we are thinking about the possibility to get the secrets from the domain, that's a little graph for it, but let me explain it again in the picture. So we've got the situation where we've got a guy, yep, here is a guy, chick, and his name is Freddy. And Freddy, let me just log computer of Freddy, I'll put on the password, and the password for the reference, it's a p@ssw0rd, enter, I'm logging onto the domain. Nothing special. So Freddy starts his work. And Freddy, unfortunately, stored the password in the Google Chrome. So I'm using Chrome Pass for this because I want to reveal the password. This is completely not a rocket science, but there is one lesson that we are learning from this actually, and that is, if you store the passwords as yourself, every app running as yourself has also access to all of your credentials. It's really serious. That's why obviously using KeePass or anything else really, any password manager makes so much sense, but relying KeePass on your own logon just brings another problem to the field, which we will also be talking about, you'll see, because I want to show you how to crack KeePass today. But anyway, so whenever we are thinking about this, it's so important to make sure that we are not storing credentials or any kind of secrets anywhere because they are relying on you. And every app that we run as yourself then basically has access to this. Now, good. Question would be, who else has access to Freddy's secrets? And this is something that it's easy to check because I'm going to get into the CQ Tools DP API. And over there, I will use our tool, which is CQ-DP API Blob Searcher. To be fair, this is my personal favorite tool in the whole toolkit that we got. Because forensically, oh, this is so good. I'm not advertising it, we just needed it, don't get me wrong. Why this is good? Because if you are under attack and you've got like a bunch of workstations that are attacked by the hackers, one of the big questions you are asking, okay, but what's our risk right now? Like, how far did they get? What kind of things they get access to? How? We are able to answer these questions without running this tool. I'll tell you, you can't, because what you need to do is to scan the workstation, every single one, and get the secrets in an ethical way and see, oh no, user has been storing data to SAP systems. That hacker could get. Let's reset it. Let's have a look. But how else without running this you would know? Let me show you how it works. It's actually pretty cool. CQDP API blob searcher, and then we're going to do /d for directory, and I'm going to shorten it a little bit because normally you will run it on the analyzed drive forensically, but here for the presentation's sake, I don't want to spend like 20 minutes waiting, I'm going to directly go to the folder that I'm interested in, yeah, so for the reference. So we've got app data, roaming, and then Google, no, not the roaming, but sorry, app data local, and then Google, and then Chrome, and then recursive search, output to the CQ tools, and then we're going to stream the whole output into dp api.txt, enter. Lovely. And a dp API, what we learn, it's a text file, but if you got some entries in this text file that look like this, it's not just a line of text, but it's actually a blob, then it means that in this file you store some kind of a secret. That's why I'm saying it's in an ethical way, because in some countries, like for example Germany, you will need like a lawyer's permissions for that and so on. So yeah, I'm sure you know better than I do if you're from Germany, but or any other places really that has a pressure on privacy that you cannot actually get users' passwords, blah, blah, blah. So this is an ethical way of doing it, because you can see that, hey, in Freddy Krueger update a local Google Chrome user data default cookies, there is actually a password stored. Now, interesting fact, how is it protected? Hold on, SHA-1 again. Yeah, that's what I was saying. Sometimes we don't want it, and we are not allowing it, but that's what you have to deal with. So our secrets are protected over there by using SHA-1, and it's not the Windows case, it's an application that's creating a secrets case. For example, KeePass uses SHA 512 and triple DES. Yeah, it's not triple DES, sorry, but AS, of course, 256. Okay, so yeah, we got that. Good. And then we are learning as well that there is a master key. And this is the master key name, that guy. So I'm going to take it, and then basically we're going to be accessing the user secrets. But how? Let's make it interesting. Let's make it super twisted. Because as I mentioned, in order to be able to get access user secrets, you have to be that user, of course, or you have to have that private key from the domain. And I want to prove to you that if I have that certificate from the domain, I'm able to get access to every single employee's secrets whatsoever. Now, you can do it offline, or you can do it online. I will do this offline because it's more linear demo-wise. So let me do it this way. Now, next, repair your computer. Then we're going to do troubleshoot, advanced options, very, very advanced command prompt as an option. And let's enlarge it a little bit, and let's keep rocking. We're going to get into the CQ tools, and over there I will use actually the tool that I bet some of you might know, which is the Mimikatz. But this, it's a secure edition of the Mimikatz with our module over there. So I'm going to do LSA dump and then cache. And then I have to type, unfortunately, Windows System32 config system, because this is where the boot key is. Here we go, we are returning to the previous section. And then we get into the Windows System32 config security, and then /kiwi, because this is where cache logon data is. And I have to override cache logon data to prove you that if I'm not ready, I don't have access, but if I have certificate, I have access. So this is also, by the way, good forensically, because if the hacker potentially deletes information about the user profile and so on, this is information that's actually stored in a registry. So you can see that, for example, Freddy Krueger is there, and the last time Freddy Krueger logged in was actually in, as you can see, 6th of May. yeah? So if there are some users logging onto this workstation and the event log is cleaned because hackers do that and stuff like that, then it's fine. You can see that one here. It's actually pretty cool. So this is overwritten already. So our command was with the /kiwi. Now I will switch off the network over there to log on with the cache logon data so that I don't have access to the domain controller and so on. And then we're going to be getting access to the user secrets in the classic way. So right now I'm not booting from the CD DVD. And just to tell you that what I've overwritten right now, it's something that's called cache logon data. Some people call it cache credentials, but please, don't call it credentials because it's not credentials. It's basically the value that is calculated based on the PBK DF2 function. So this is this section on the top of the slide. And this basically, in Windows case, has hmax1, the username, 10,240 iterations on 16 blocks, and DCC1. And the DCC1 has been used up to including Windows XP. And DCC1, it's nothing but MD4 on the top of the username, joined with the MD4 of the user's password, check, and on the top of that we calculate another MD4. That's DCC1. And that currently is just a part of the algorithm of it. So PBK DF2 is actually pretty good. So moving forward, it's very good. Yeah? Moving forward, Freddy. Let's come back to our friend. So if we're going to be trying to log in with the password like we tried last time, it doesn't work because we have overwritten the cache logon data. With what kind of password we've overwritten it? Well, we are using Mimikatz. So the password for the logging on to the domain user is going to be Mimikatz. Let's give it a try. Mimikatz. Here we go. Once again, there was a little typo, and here we go. So this is a violation, actually, because I'm logging on with a different password to the domain user right now. Yeah. Now I can do mess as Freddy Krueger and then say, oh, Freddy, you are not behaving well. That was Freddy. Yeah. So this is actually pretty cool because in logs it's going to be Freddy. Yeah. But anyway, that's a different part of the story. Let's see what we can do. Chrome Pass. Yeah, it's going to take a while because, as you could see in the past, it was very quick. We could get the password, but right now we cannot because we are, in fact, over here trying to get access to the master keys that we cannot because we use a different password / different password hash. So let's give it a try, and let's use that certificate from the domain to make a complete blast so that we see how powerful that certificate is. And let's do it like this. We're going to get into the CQ tools, good, and then we're going to get into the, in this case, CQ hash calculator, and I'm going to calculate the hash on the top of my current password, so Mimikatz1. In the meantime, let me enlarge. You can see that there is no password over there. So we are fighting for this one, not being Freddy at the same time. Okay, and what that's gonna take. First of all, we're gonna get into the CQ master key AD in the DP API toolkit. Yeah, so we got a CQ master key AD, and then we will need to specify a couple of options here. One option, it's gonna be PFX, so that private key from the domain. Exported PFX. Second one, it's going to be new hash, which is actually this guy over there. Yeah? And another one, it's going to be the file. Which file? Remember master key container? Exactly. So this is the moment where we are putting on the master key container of the user, which is in Freddy Krueger, AppData, roaming, Microsoft, Protect, SID, and then there was this B55 key that we were displaying in a text file. Yeah? So this is where we got it. This is this file. This has two master keys. MK1 that we have no access to because the password is different, and MK2 that we have access to, hopefully, because it has been protected by the public key of the domain and because we have a private. Let's see. So we're going to take this guy, shift right click, copy as path, good, and then we're going to put that on, enter, and then we've got a new master key being written over there. So let me just rename it. So it's a quick operation, _ good, and then we've got AD modified, which we will actually put here. tick, tick, like that, perfect. And then one more thing, because it has this blank icon, I have to make it system and hidden. And in fact, our tool already generates this command, so I can just copy it, and that's it. Enter. Yeah, and let's have a look what we got. And to be fair, if it doesn't work, then I can go and sell coconuts to the rest of my life on the beach. So there's a little bit of adrenaline. Let's see. F5. No, not today. Good. I'm staying in cyber. Okay, anyway. What's the conclusion? Conclusion is very simple. We are a little doomed. Because it's a password of every single user that is provided by anybody who has this little private key on the domain. So if you don't have a trust to your domain, and you shouldn't, to be fair, then hopefully you've got solutions like privileged access management, that the domain admin is like a regular service technical account, not the human being actually, and that you monitor precisely what is happening on the servers, process-wise, session-wise, DLL-wise, script-wise, and so on, so that we get a complete editing and analysis of everything that's basically happening on the servers and workstations too. Because if the incident happens, the first thing I do, I ask the team on site, guys, show me everything that happened on the servers that are under attack for the past week. Give me the list of processes that we're executing, list of sessions, list of logons, list of everything. And they're like, but where can we get that from? This is one of these favorite questions that you got in the projects, yeah? And then they're like, they don't have it. So how can we build a full picture? We cannot. And this is really serious. Yeah. We're not done yet. Okay, good. So let's just add up. What about some other secrets that we got? So whenever, for example, we've got KeePass, yeah, how can we protect ourselves? And I'm going to answer this question in a little twisted way, if you don't mind, because my job is to show you all the possible threats around that kind of activities. So have a look. Like in the user's data, I've got CQBase. That's a KeePass database. I want to open it up and put the password, let's say secure. Yeah, here we go. And then, well, no, it doesn't work. So it's a KeePass database of the user. Now, how can I get access to that? Well, KeePass database of the user, it's empty. It's relying on the data protection API too, like many other things. And you can actually see that by opening the protected user key.bin, which is a file that protects the KeePass. So eventually, this DP API has a very characteristic header, and I shouldn't maybe open it in Notepad, but in some kind of a hex editor, but this one is actually pretty characteristic. So you've got this exe kind of looking like a beginning. This is the header of a DP API. Now, in order to be able to get access to the user's KeePass, then one of the things that we will need to get, and let me get into the master key of the user, which is this one. You need to get the master key, of course, of the user, and you need to get a couple of components. One of these components is going to be, let me just get the tool, to get the KeePass entropy. Now, unfortunately, it's stored basically in the registry, and it's like the same. So it's easy to get it. But in order to get access to the KeePass database, I have to do CQ, DP API, blob decryptor. And for that, I need a master key of the user, entropy, and the blob. So it's very easy, because I can do the same tool once again, but this time, master key of the user. So that's this B55 master key that we are talking about, but I have this in the clear text decrypted already. And then we've got an entropy, and entropy, good, no typos, and I'm going to get this entropy from the tool, so bring it on. So I'm going to put this on, and then the blob, and the blob we are working on is the key that protects the KeePass database, and that's the protected user key.bin, and that's it. And what I'm getting over there, it's a decrypted protected user key bin, so decrypted data protection API secret. Normally this would be like a Google Chrome password, but because KeePass has one more component in the middle, we have to work on this one more component. And at the end, what is the case is that we can get that component, so here we go, and use it against our KeePass database. So we're going to do CQ, DPAPI, KeePass, DB decryptor, yeah, once again. And this one has two parameters, /k for key, /f for file, which is actually our KeePass database. So CQ base 1 KDBX, enter. And let me show you, because over there, whenever we are like putting this value here, just for the reference, this is a decrypted data protection API secrets, and at the same time a key that protects basically the KeePass. And the file, it's basically the KeePass database. So only by having this, we manage to regenerate the KeePass database, and I will allow myself to open it. Now the password, I already know, that's secure, enter, and that shows me the passwords of the user. Which proves the point that we should be absolutely careful with our domain security, and we should not really rely on it, and we should do everything to have a well-designed, well-monitored environment. And my favorite approach is always assume the breach, so that we basically feel we are under attack every day, and at the same time, we design our infrastructure to know as much as we can. So that's basically the setup. Now, the very last thing, and I am done over there, and this is like a cherry on the top, if you don't mind. It's related with that data protection API NG, with that KDS root key that we were extracting over there. And as you can see, KDS root key in general is actually used as a part of the algorithm for the DPAPI NG to protect a couple of secrets in Windows. One of these secrets, and that's super exciting, and let me show you, is related with, for example, certificate files. So you know when you've got a PFX file, we've got a possibility to protect it by, for example, exporting it. So let me show you how to do it. Exporting it to the, like some file. So for example, we can do here export, next, export the private key, yes, PFX, and now this is what I'm talking about. This is old school, right? So we are used to export PFXs with the password. It's very brute forceable, in general makes no sense. But this makes sense. This is seed protection. You can specify that you would like to have it for Freddy, for example. Yeah, for Freddy Krueger as a user, boom. Next, and then it's gonna be for Freddy. So that only Freddy can open it. And I get here Blizzard, which is already exported. Next, display password. And we are learning over there that there is actually a password that is attached as a blob to the PFX file. This is a good way, by the way, of doing it. But of course, everybody has a trade-off. And you're here and I'm here to show you that that is also threatened if we have a KDS root key. And we can, in fact, do it while we've got our KDS root key available, so the one that I've been extracting, so everything has a purpose. And for that, I'm going to get into the CQ DPAPI PFX decryptor tool. And within the tool, enter, we are here specifying the PFX and the master key. And in fact, I got it all. So the master is going to be this one. And the PFX file that we are working on, it's called Blizzard. And as you see, even though I'm not in this virtual machine, I am outside. But the only thing I need to have, it's that master key from the domain and that certificate. I'm able to get the password IXF that will allow me to get access to the PFXs. So everything is so connected in Windows in terms of the cryptography, and even though DPAPI sounds like a very unpopular niche little type of a subject, every cybersecurity specialist needs to know how and what is our data protection in the systems that we use, especially in Windows. Yeah? And also we need to know that if you store a document and if you use any kind of type of encryption, you need to know what it relies on, where is the key stored, yeah? What are the factors in general around it, because it might be that all these beautiful things that we are using, they actually rely in one point over there that has been compromised maybe a long time ago. And I'm talking here about the private key that's stored in a domain. So finalizing the presentation, we might be wondering, okay, but could MFA help it? Well, depends on the situation where the hacker is, yeah? When we are like just outside and doing the password guessing, then obviously because that's what the MFA is for, so answer is yes. But if someone is basically already in your system, then maybe they could extract the cookies. So answer is MFA will minimize the risk, that's for sure. Auditing, monitoring, knowing what runs on the servers, that's like a must in nowadays. Every incident suffers so much, in my opinion. We could have been so much more efficient if we knew what was going on. But the answer is, we don't have that data. Oh no. Or literally, this case from the weekend, the guys actually restored the servers in place. So I'll probably live like 5 years shorter because I was like, yeah, it's this. Like the evidence is just like wasted. And you're like, what to do? So we need to know basically what kind of risks we are dealing with. And at the same time, we need to know where our secrets are stored and what's the risk we are dealing with when there was an incident. Zero trust, always. Investing into awareness so people actually use KeePass. But at the same time, we need to know, and this is an important part, where our credentials are, and credentials aren't always stored in the form of a password. And, of course, to apply what we learned today, initiating internal awareness campaigns about our passwords, so to say. Performing an audit and reviewing basically the places where the passwords are stored. Understanding DPAPI, because it's not leaving you. You're going to be living with DPAPI. And at the same time, adjustments to the architecture, potentially, to adjust our cryptographic security. So if you guys have any questions, please feel free to ask them. And as always, I brought some stickers and how do you call beer openers? Sorry, not beer, bottle openers. Yeah, so sorry. Here we go. So bottle openers, and yeah, thank you so much. Hopefully you learned something in the morning. Sorry for the torture at 8:30, but thanks a lot for coming. And for sure, you are interested in DPI, and thank you for that. And of course, hopefully see you on the Wednesday session. Thank you.